Hey guys, Travis from Hammond Engineering here. Come in on the weekend to play with a new toy that I got. So this is a Renishaw QC20 BallBar system. I'll open it up first and then I'll give you guys a look at what it is and I'll try to explain what it does. And then I'm going to try and use it. I've never used one before, so I thought I'd give it a crack, and they seem pretty simple. I've watched the instruction videos and we'll all learn together. So, what we've got in here, we've got our little base section that goes on the mill table. This is a calibrator. So, this is the main section here, which is a little wireless tester. Basically, it just measures how much that moves very accurately. I can't remember the accuracy right now, but very accurate. So basically this is a calibration stand, so you can put it in there and calibrate it to exactly what this says. Different calibrators for different extensions, so you can add more extensions. There's 3 different sizes of extensions in here. You can also get some extra things that are not in this kit because I haven't bought them. You can get a thing for doing shorter distances, which allows you to do that distance, and you can also get other attachments for specific different machines. So what this actually does is you get this piece, goes on your mill table, and you clamp it down, you orient it. There's a bit of a process for that. Then you get this little guy, goes in your mill spindle. So they both have, there's sort of a magnetic mount that has these little, I guess, standoffs that the balls on the BallBar system go into, and they magnet in place. So that holds them in place. So basically you have this on your mill table, this in your spindle, and you magnet that bad boy in there, and you tell your mill to do a circle, and you tell the software that you're doing that circle, and then it measures how round your circle is. And it also measures a lot of other things like following errors and backlash and things like this. So what that lets you do is adjust some parameters in your machine, or see that you need to do some actual more physical maintenance, and then you can get more accuracy or better finishes is sort of the main thing that I'm going for. Because I've been having some surface finish issues with my Mitsuki, and I've been adjusting some servo gain and backlash parameters to try and make it better, but I've just been taking a stab in the dark. And this is going to give me some actual data, so I know that I'm changing the right thing and hopefully get some good results. Up under here, what have we got? So we've got some lovely Renishaw blue tack there. BallBar test reports, so you can stick it on the machine. You know, keep some record of how accurate the machine was at whatever date. Calibration certificates for the calibrator and for the actual QC20. Just warranty info. Yep, software guide, cool. And some stickers, great. All right, let's get stuck in. All right, got my laptop set up here. Just gonna download the Renishaw software, I guess. I've not really gone through this process at all yet, so I'm doing a bit of learning here with you. In the nice old video that they had up on YouTube, the old system came with a CD, but I don't even know if I have a computer with a CD-ROM drive anymore. All right, BallBar 20 software. Let's download this bad boy. Alright, let's install this bad boy. Accept everything, install. Installed. Alright, let's see if we can get this bad boy to work. So, throw our receiver in there. Grab our little base plate doober, throw it down there, making sure there's plenty of room to do a 100mm circle, which is 200mm diameter. There's plenty of that. So we leave this loose, so that clamps it down. Lift it up, it's loose, and it's loose in all axes as well. So that allows you to align the spindle with it perfectly. Bring our spindle down. Come somewhere over in the ballpark. Get down. So we want to make sure that we're not pushing down on it and we're not up against the full height of it as well. It wants to be floating somewhere within that degree of motion there. Don't want it up against any of the edges to make sure that it actually is in line. Then we use this little ball, which is just a ball. Put it in between, and that will allow that to pull up into place. Now, we've definitely got a good couple of mil there, so I'm going to pull that up in place and come down another couple of mil. So we're definitely somewhere in the middle of the range. Then we can lock this down, so that stops the base from moving. They're definitely in line because the ball is held in with the magnets and that's holding it in place. So now we can go up from there and we'll just pull away from the magnets. We know I've missed something there. I need to set my Z with that loose as well. So we're going to come down a bit there. Alright, we're in the middle. Clamp it down. Now what we're going to do, jump on the control and we're going to set our work coordinates. So we're going to put it on work offset G54 because that's what we're going to use. And then we will go set work offsets, set X0, set Y0, set Z0. There you go, we're at 0, 0, 0 with our little placeholder ball in there. So now we can come up away from it and remove that. Now we need a program. So the software will make a program for you. It's a pretty basic program, but why not get the software to do it and then I can't fat finger anything. So it's just, you know, make sure it's in millimeters, puts you in G54, which we just set, makes it in absolute dimensions, XY plane, makes it so it won't stop between the moves, sets the feed rate at 1000 because that's what we've told the test we're going to be doing. You can test at all different feed rates, and I will be testing at different feed rates because you kind of want to test at the feed rate that you're going to be cutting at. And I'm sort of more doing this so I can get nicer finishes when I'm doing ball end mill profiling. I'm normally running that somewhere around 2,500 millimeters per minute. So I will eventually run it at that, but just for now I'm just learning how to use this, so we're going to go with 1000 because that seems like a more reasonable speed. Just brings it down to x minus 101.5 and y 0. So it will be just off to the left of where the base is. And then it stops, so you can load the actual BallBar. I actually did notice that this does not do anything in Z, so I guess you already have to have it at the right height in Z. So you've got to have it sitting exactly where we are right now, because it's not going to move anywhere in Z. And then M0 stops so you can load the BallBar, and then G01 comes into X minus 100. Now let's see if we can open it on the control. Oh no, around here. Programs. Infusion 9001. Look at that, there it is. Cool. Alright, now we want to dry run it, because not dry running it would be dumb. We'll come across out of the way, bring ourselves down to our Z0. Turn our feed rates right down, just a little tiny bit there, and we'll hit the go button. Ah, oh, syntax error, you're joking. Alright, let's do a little bit of a change here. Alright, round 50. Hey look, it's doing things. And the speed up. So we've gone to minus 100.5 and we've stopped. So this is where we're ready to actually start tests. So put it on single block, we hit go and it should just come into minus 100. There we go. Now it should start doing a counterclockwise loop. And there it goes, doing a counterclockwise loop. Going through y minus 100. It does one full circle, then another full circle. So it uses half of the circle as a sort of lead in, and then uses a full circle to measure, and then another half circle as a lead out. You can make those lead in and outs a lot smaller, like you can make them 20 degrees or something like that, but the programming is just a lot more simple when it's doing full circles. Just less chance of fat fingering things if you are typing it in yourself. It'll come around back to sort of where it started, and then it'll go out to turn the BallBar off, and then it'll stop, and then we go back in and go the other direction. Let's take a look at this thing. Around. Back at 0, pulls out, stops. That's it, back at the start of the program. Alright, so that looked like it all did what we want it to do. Let's see if we can actually set it up and do it properly. So back in the software, we're back here. We've got a test set up, 100mm diameter, 1000 millimeters a minute. We're ready. Alright, next. Now we've got to connect this bad boy. Do that up, that's turned on. QC20. Search for BallBar device. Right, that's got to be it, doesn't it? It's the only one there. Click that. That's there. Cool. That's what we want. BallBar not connected. There you go. Calibration reminder. Renishaw recommends that the BallBars are recalibrated every 12 months. If you would like to recalibrate, contact. Alright, we're not going to do that. Remind me in 3 months. Cool. Alright. Connected. If the test needs a calibrated length BallBar, fit the BallBar to the length calibration as shown and check the serial number and length. Let's throw that in there. Make sure it's sitting there snug. So right there we're sitting at 100.017-ish. We want to calibrate that, so we're going to click that, and there we are. 99.9999, which is what the calibrator actually is there, if this would ever focus. So now we're good. So we'll go next. Now we're ready to run the BallBar test. So we're only doing one. And we've got to click the start the program. Line the machine spindle, move the machine to the start point and fit the BallBar. Okay, so that was the first stop in our program. So we can run our program until the first stop. Make sure our feed rate's back on 100. Now we can grab the BallBar and put it in. And there we are, on top of our thing. As you can see, we're already not very accurate. So we should be at minus 101.5 and we're at 100.98, so 0.4 something of error. Alright, hit the start button and see what happens. And we're running. Just waiting to start because remember it does that full 180 first. Or more than 180? What's it doing here? Okay, I don't know why it didn't start. Oh, maybe because I didn't push the start button on here. That's probably got something to do with it. We'll just stop this when it gets back around to the start. So we'll put it on single block so it'll pull up over the side there. Over the side, pull back out, we'll hit reset, pull that out, start again, take single block off. Okay, so now it's ready for this to go in. Put it in. Now let's actually hit the go button. Now it's rating. And it's flashing blue. Righto, go. Pushed in. It's capturing. So it's doing 180 degrees of lead in, I guess. And there you go, now it's in blue, so this is the actual run. It's actually checking it. From what it looks like, I would say it's pretty terrible. But this is why we got this tool, so that we can actually check things. Looks reasonably consistent over the other run. Bear in mind I have absolutely no idea what the hell I'm looking at here. I am just learning and bringing you along for the ride. And now we're on our deceleration. And then it'll stop and it'll go back the other direction. So get back around to the start of run number 1. Pulls out, and now we're ready for run number 2. So it's just waiting for the feed in. Doesn't look like I have to press anything else on there. So we'll hit cycle start again, goes in and starts going the other direction. And there we go. Same thing, 180 degrees of lead in, I guess. Oh, there you go, it calls it acceleration and deceleration down in the bottom left there. You can also see there we've got 5 micron deviations, so each little tick there is 5 micron. So even though it sort of looks like a big amount of error, it's really not a lot. Alright, we're done. Cool. So I'm going to pull out this bad boy now. There's no point having an expensive thing sitting in the machine. Undo the battery cover till the light turns off. Put it away, safe and sound. Let's have a look at some info on here. Alright. Detailed analysis. So, our error, positional tolerance, 61 micron, best fit radius, 99.992. So we're 8 micron undersize, basically, which is not bad. Here's what our sort of problems are coming from. So 21%, we've got a reversal spike in Y. So I think that's what you can see there, that little dunk there and there. So that might be a servo gain sort of deal where I've made the gain too high possibly. So it's kind of coming back quicker than it should be. So I might have to soften that off to try and get rid of that spike. But that's what 21% of our error is from that. 18% of our error is from squareness. So you can see there that that dashed circle is, you know, perfect circle. Where outside here, outside there, inside here, inside there. So it's like it's sort of kicked off on an angle a little bit. Backlash in Y, so 6.3 micron one way, 2.1 micron the other way, so we could probably do some adjustment there. Cyclic error in Y, not sure about that. There's all information on all of this if I click through into it, and that is what I'll do off screen, but just thought I would show you all. So basically what I'm going to do is I'm going to go through all of this. I'm going to play around with some settings. I've played around with a whole heap of things, and in the past I've basically just, you know, cut some little test pieces like this to try and get a finish that I was looking for or something like that, and adjusted servo gain and other settings to try and get a better result there. But I've just been doing it by fiddling, and probably not the best way to do things, especially in an industry like this where everything's about accuracy and repeatability. And I found when I was doing that, I would possibly get other problems that would come from it. So this is my solution to give me some actual real hard data. Then I can make changes and see what the results are from the changes. So hopefully I'll come back with another video with a little bit more info about how I've gone with adjusting things and how I've been able to change this result. I'll also try it at some different feed rates, like I said, because generally when I'm doing finishing cuts like that, I'm not doing it at 1,000 millimeters a minute. I'm doing it at 2,500, 3,500. Otherwise, the parts I'm making would take forever and cost $1 million. So I'm trying to get better finishes at those faster feed rates so that I don't have to take way too long to do things. But I also want to maintain the ability to, you know, machine bearing bores and things like that to a close enough tolerance that they're workable without having to use a boring head. Hope this helped. Thanks for watching. Like, subscribe, notification bell, blah, 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 and I'll do some more videos.